There we go. Back. Okay. So one more time, if I do that, if I want to find area using StatCrunch, and I want to find the total scores that are above 1.33 standard deviations, I'm going to make sure my mean is 0, my standard deviation is 1, and I can find the area to the right of 1.33, which is also that, okay? If I'm not using z-scores, I can put in the mean and standard deviation of my actual values. So I'll put those in as well. So there's the mean and standard deviation. If the mean is 100, the mean IQ score is 100, and the standard deviation is 15, I want to find out what percentage of all people or adults score higher than 120 on their IQ test. Okay, so I want to find greater than 120 with the mean and standard deviation, and there we find out it's 0.09 or about 9%. Now remember, we can also interpret that as if I select some adult at random, what is the probability that their score is higher than 120? The value will be about 9%. That means 9% of all that people score above 120 on their IQs. Cool? Cool, cool, cool. All right. So let's do this next. So let's look at some examples. This is their examples. Okay, so let's take a look and see how we do z-scores again real quick. This is the examples that I gave you. And I will also post this again with the answers. I'm going to put in some of the answers here and I'll post them with the answers so you guys have some things to look at. Okay. All right, so here's our example. Suppose that the distribution of foot lengths of adult males is approximately normal. Okay, with a mean of 11 and a standard deviation of 1.5. Okay, so a mean of 11 inches and standard deviation is 1.5 inches. What would be the z-score for these randomly selected men if they have a shoe size of 9.5? Okay, well, if they have a score of 9.5, notice that is below the mean. So are we going to have a positive z-score or a negative z-score? I'm hearing everybody out there say negative. Good, that's awesome. Cool. So simply what we're going to do is take 9.5 minus 11, and that gives you negative 1.5. Or over here, I can do 9.5 minus 11, and we're going to divide that by 1.5 as well, okay? And we can find out that our value is exactly negative 1. And the reason why is because 9.5 is exactly 1.5 inches below the mean. And since the standard deviation is 1.5 inches, a person with 9.5 inch feet would be exactly 1 standard deviation below the mean. How about 13.7 inches? Well, that obviously would give me a positive z-score, 13.7 minus the 11, okay, divided by 1.5. And when you're doing this again, make sure you subtract the top part first before you divide by the bottom. And that's going to be a z-score of 1.8. Okay. So 1.8, and again, how do we interpret z-scores? It's always the number of standard deviations above or below the mean. Okay. And how about we have a guy that has only a feet that has 7 inches? So what would their z-score be? So 7 minus 11, that's negative 4. Negative 4 divided by 1.5. And it's going to be negative 0.267 if we round it up. Okay. Now, of these 3 z-scores, I also asked the question, are any of these foot lengths unusual in length? Which one of these 3 would be unusual? Well, remember, unusual in our case is going to be anything that's above or below 2 standard deviations from the mean. So the only one that would be an unusual foot length would be this one, would be the 7 inch. And the reason why is because it's unusually small, because he's got small feet. He's more than 2 standard deviations below the mean, and that occurs less than 5% of the time. actually incurs less than 2.5% of the time. So we would consider that unusual. So anything above or below 2 standard deviations, we usually consider to be unusual. Okay. All right. So now let's get into the last part. How do we handle questions like this? And again, I'm going to be using my finger, and I'm also going to be using StatCrunch, and I'll also show you how to use the table of values as well to see what we can do with that. Okay. Cool. All right. So here's our example. A GRE test is required for admission to many U.S. graduate schools. Student scores on the quantitative portion follow a normal distribution with a mean of 150 and a standard deviation of 8.8. What proportion of combined GRE scores can be expected to be over 160? Let me zoom in a little bit on this. Okay. So first of all, again, you do not have to do this on your curve. The only reason why I'm drawing this out on your curve is to try to make you understand exactly what it is we're trying to find. And again, you can use StatCrunch or you can use Z-scores to help you determine any of these as well. Okay. So what proportion of GRE scores can be expected to be over 160? So let's start off by stating the question using some of our symbols. We want to find the probability that X, which is a random score, if I can draw. Try that again. What proportion of X is expected to be greater than 160? So we've stated that like that, okay? So let's go back over to here. We've got 150, that's our mean. 8.8 is our standard deviation. So one standard deviation is going to be about 158.8. Okay? So we're looking at 160. So 160 is going to be a little more than one standard deviation above the mean. And what we want to do is we want to find the area that's to the right of this. Okay? So what combined GRE scores can be expected to be over 160? Well, you've got two options. If you do not have access to StatCrunch, you're going to use your table. And you're going to convert this to a Z-score at first. So I'm going to take 160 minus 150, which is 10, and then divide it by 8.8, which gives me a Z-score of about 1.14. So if you're using your table, you want to find the probability that Z is greater than 1.14. 1.14. Okay? Cool? So if you're using your table, you're going to go to your Z-score and you're going to try to find the table at 1.14. I'm going to try to show you that real quick. Be patient with me. And then I'll also show you using StatCrunch. So can everybody see my normal table? This is the kind of looks like what your table is in table 5, which is in the back of your book. Notice again, it's got half the pages has negative Z-scores. So you can see all along the left there, there's negative Z-scores. And then the other half of the page will be your positive Z-scores. Okay. We wanted to find the Z-scores that was greater than 1.14. So I'm going to go find 1.14 on this table. So there's 1.1 right there. I'm going to highlight that. Okay. So there's 1.1, and across the top, there's my 0.04. Okay. Maybe. So there's 1.1. Hold on. 1.1. Are you going to let me do this or not? There's 1.1 and there's the 0.4. We're going to find the intersection of the two. We can see that it's right there. Okay, I'm going to write down that 0.8729 in a second. I'll go back to my paper and do that in a second. So everybody remember 0.8729. Now, 0.8729 is the area to the left of the curve because your table only finds area to the left. If we want to find area to the right, we have to subtract that value from 1. Okay? We have to subtract that value from 1. So let me go back to my paper for a second. okay? And we're simply going to subtract that from 1. So the 1 minus the 0.8729 is equal to 0.1271. Then, of course, again, we would also have to interpret that number. So what does that 0.1271 represent? That is the proportion of scores that can be expected to be over 160. Or we can say it's the probability that a randomly selected adult would score over 160 on their GRE test. Okay, let me show you how to do that in StatCrunch now, because again, most of you guys will probably have access to StatCrunch, and it'll be a lot easier to do that way. So I'm going to go back to StatCrunch. Okay. And in StatCrunch, we simply have to put in the mean. Okay. Our mean score was 150. Was it 150? Hold on one second. I've already forgot what it was. Oh, 158.8, right. 150 and 8.8. Okay. So we're going to put in 150. Our standard deviation was 8.8. And we want to find the percentage of students that scored over 160. So we're going to put in 160. I'm going to hit compute. And there's our value of about 12.79. I think it was about the same as what we got when we used our table as well. 0.1279. Okay. Now notice up here on your normal thing, it also gives you the 68, 95, 99.7 ticks. Is what I showed you on when I drew my curve as well. There's the one standard deviation above the mean, 158.8. There's 160, which is a little to the right of it. And we find that our area is about 12.79% or 0.1279. Cool so far? So again, when we're finding the area underneath a normal distribution, the two most important things are making sure you know your parameters. What is your mean? What is your standard deviation? And the second thing is, which area are we finding? Are we finding the area to the left of a value, or are we finding the area to the right of a value? Or again, we can always find area between values as well. Okay? What proportion of combined GRE scores can we expect to be under 160? Well, we've already figured that one out to begin with using our z-scores. We already figured that one. What proportion of scores can be under 160? Now again, always start off by stating the problem that you're looking for. What probability of X is going to be less than 160? If you're using z-scores, and in this case, we're finding the area to the left of the curve. So that's exactly what you're going to punch into your StatCrunch. You would put in probability that X is going to be less than or equal to, it's going to give you the same value as less than 160. So we've already figured that out from the other one, and that was 0.8729. Okay? So the area that's under 160 plus the area that's above 160 should always equal 1, or 100% of your values. Okay? Let's see what else we can do with this. What proportion of combined GRE scores can be expected to be between 155 and 160? Now we want to find area between. So for this point, we're going to find the probability that X is going to be between 155 and 160. 155 and 160. Okay, so we can also do that in StatCrunch. I'll show you how to do that in StatCrunch. And I will also show you how to do that using z-scores in a second. So if we're using the StatCrunch, we're going to use the same mean, same standard deviation, but this time we're going to go between So this one, and we go down to the bottom here, we're going to try between two values. We want to find between 155 and 160. So notice again, that's exactly how the StatCrunch has it set up, exactly the same way that I wrote it. We're going to hit compute, and notice again, now it's going to find the area between 155 and 160, and we're going to find that area is 0.1570, okay, or 15.7%. Okay. Cool. So 15.7% of all GRE scores are going to be between 155 and 160. All right. Now, how do we do that with Z-scores? Well, we could do that with Z-scores as well. We already know what the Z-score is for 160, and that was 1.14. We can also find the Z-score for 155.
Excuse me.
Which is 0.57. 0.57 and 1.14. Okay. So 0.57 was the Z-score for 155, and 1.14 was the Z-score for 160. Now, how can we use our table for this? I'm going to show you real quick. We're going to find both the proportions for both 0.57 and for 1.14. Go to my normal table. There was 1.14. It was 0.8729. And we also want the Z-score for 0.57. So I'm going to do that as well. 0.57. So over here, there's 0.5, and there's the 7 at the top. We want to find the intersection of those two rows and columns. So 0.57 is right there. Can everybody see that? 0.7157. That's the Z-score for 0.57. And in red, we have 0.8729. Okay? Okay. So I'm going to write that down real quick. 0.8. 0.7157. Those are our two scores. And we just simply subtract those two values. We could just simply subtract those two values. So we're going to subtract 0.8729 minus 0.7157. .8729 minus 0.7157, and that's going to also equal 0.1572, which is a little different than when we did this one. But of course, we also rounded off the Z-scores, and your StatCrunch is not going to round anything off, at least not as much as we did. But it's about the same thing, so about 15.7%. So if you do not have access to StatCrunch, but you have the table, you can always find any of these areas by just simply converting all of your raw scores, that's up here, taking all your X's and changing them to Z's. Once you change them to Z's, you've changed everything to a standard curve, and there's always one set of proportions for your standard curves, and that's in table 5 of your book, okay? So how do we find the probability that a randomly selected student will score over 145? But by now you probably know we're going to start with this, greater than or equal to 145. Okay, if you're using StatCrunch, you go right in there, put your same mean, same standard deviation, and look for the area to the right of 145. If you're using Z-scores, what are you going to do with that 145? To a Z-score. change it to a z-score, okay? And we can also do that to find a probability that a randomly selected student will score less than 150. So again, you're going to use StatCrunch, you're going to use that. So always start off by stating the problem, and then you're going to calculate the probability. And then of course, don't forget, I'm not going to try to do it with my 5-year-old handwriting, but you also try to interpret those values as well. Okay, so those 3 things. All right, let's go on real quick. One last thing I want to show you. How do we work backwards? Well, we find a percentile. Well, that's a percentile. That's the same thing. What percentile rank of a student who earns a quantitative GRE score of 142? So what is a percentile? Okay, so we have to go back and interpret what that value is. So we want to find out, what is a percentile? Percentile is always going to be the percentage of scores that are less than or equal to the value in question. So we want to find out what percentage of all scores are going to be less than 142 if we want to find a percentile. Okay, so we want to find the percentage of all x's that are less than 142. That would be the percentile. Okay, so nothing different there. We can always do that as well. Okay, cool beans? Cool. All right, now in part G, what if I give you a percentage and we have to work backwards and we want to find the score that matches that? So look at the question G real quick. Historically, the Department of History at NYU admitted students whose quantitative GRE scores at least the 61st percentile. At least the 64th percentile. What is the lowest GRE score of the student that they admit? What's the lowest score that you can get and still be admitted to NYU's history? Okay? So we're going to give you the percentage and you have to find the score that matches. So let's see if I can do this with my 5-year-old handwriting. Okay? So let's go back. Let's take a look again. Remember, our mean score is 150. Now, what is the percentile for 150? The percentile at 150, it's right smack dab in the middle. So what percentage would that be? Everybody's thinking to themselves, that would be 50%. So your 50th percentile would be a 150. 50th percentile, but we want the 61st percentile. So we want to go a little more than that, okay? We want to go a little more than that. We want to find a score that's about here. Okay, and so we know that this is 61% or 0.61. And we want to find the actual score, which is x. So we want to find the probability that x is less than what value that's going to equal 0.61. So we want to find that value. So we actually want to work backwards, okay? We actually want to work backwards. So let me show you first using StatCrunch because it's a little easier using StatCrunch. And then this is a little more complicated, but we'll show you that as well, okay? So let's start with the StatCrunch. So we're going to keep the 150 and the 1.8 there. I'm going to go back to standard. I'm going to erase this bottom part here for a second. Now, simply all we have to do is we have to make sure that we're less than, because we're doing percentiles. Percentile is always less than or equal to. But instead of putting in a value for x, we're actually going to put the percentage in and work our way backwards, and it's going to give us the score that we want. So I'm going to put in 0.61 or 0.61. Okay, we want the 61st percentile, and then I'm going to hit compute, and it's simply going to give me a raw score back. So what score does a person need to get in order to be at the 61st percentile? They need to score 152.45, or we'll probably round up if they don't do decimals. We have to score about a 153 to do that. Okay, so we move backwards. We just simply put the percentage in, 0.61. Remember, percentile is area to the left, or less than or equal to, not greater than. And then all we simply did is put the percentage in and hit compute, and it gave us a raw value back. okay? So a score of 153 will put us at the 61st percentile. A score of 153 will put us at the 60th percentile, 61st percentile. Now, if you're using this, if you're using table, if you're using z-scores, how do we do it that way? Okay, so let me show you that real quick. The first thing we're going to do is we're going to find the z-score that matches up for 61%. So let me erase this real quick. This is a little more complicated, which is why if you have StatCrunch, I recommend using the StatCrunch. So we want to find the probability that x is less than what value going to be equal to 0.61. Well, first of all, we're going to find the z-score that matches up with that. Okay? So the z of 61 percentile is going to be equal to something. Okay? So let me show you how we find that. Back to my table. Let me erase some of these values. So what I'm looking for is I'm going to search for the score that's closest to 61%. So I can see all these values up here. Okay. It looks like this value right here is my closest to about 61%. Okay. I want to find the z-score that matches up with that value. What's the z-score that matches up with that? And I can see that the z-score is 0.28. There's the 8 across the top. Okay. So one more time. Let's see if I can do this. There's my 61%. And the z-score that matches up with that is 0.28. Okay. 0.28. So I'm going to put that in there, 0.28. Now, actually, I can work backwards now, and I can actually find out what is the raw value going to be using my z formula now. I can actually work backwards and find out what that's going to be. Okay. So here we go. Remember, our z is equal to x minus the mean all over the standard deviation. Now we know our z value is 0.28. We don't know what x is, but we know the mean is 155, and my standard deviation is 8.8. Okay, so what we're going to do is we're simply going to work backwards now, use a little bit of algebra, and we're actually going to solve for x to find out what x needs to be. First thing we're going to do is take 8.8 and multiply it by 0.28. Okay. First thing we're going to do is multiply both sides by 8.8. And that's going to give me 2.464 equals x minus 155. Oh, I'm sorry, 150. 150. Okay, the mean was 150. Okay, not 155. Cool, mean was 150. Now, what's our last step then? How do you get rid of a minus 150? Plus 150. And we can see that x is equal to 152.46, which is what we got before. So we would round that up to about 153. That's it. Okay. That's how we could find it. All right. Last one where it says up there, determine the GRE scores that make up the middle 95% of all scores, the middle 95%. Well, we know the middle 95% is about 2 standard deviations above and below the mean. So we can actually do this 2 ways. We can just simply use the empirical rule. What's going to make up 95% of our data? In other words, we want to find out what are our 2 values? What scores will make up the middle 95%? Middle 95%. Okay? So, 1, we can do this in StatCrunch. Okay, to show you how we do this, we're going to go to between. But instead of putting in values, I'm just going to put in 95% over here, 0.95, and it's going to give me the 2 values that I need to go between in order to get that, okay? So what values are going to represent the middle 95%? That scores between 132.7 or 132.8 and 167.2. Okay, so that's all we simply did. When we want to find the middle 95%, so we can go to between, keep the same mean, same standard deviation, and we're going to put in the percentage, which is 95%. It's going to find the area that's in between them. Cool beans? And that's our values of our data between. Let's shrink that up so the screens are up there, okay? We got 0.95%. We can see that's going to be our middle 95%. All right. Now we can also do this by using z-scores, or we can just simply use the 95 rule or 68-95 rule. 95% is 2 standard deviations. So we can just simply take 2 times our standard deviation, which was 8.8. 2 times 8.8, which is 17.6. Okay, so that's 17.6 points above the mean and 17.6 below the mean. So we can take the 150 plus 17.6, and we can take the 150 minus 17.6. Okay. 32.4, 67.6, which is what we got before, okay? Not the same. That's it. All right, let's go back to that real quick. And I think that's it for the night. That's all we got. So let's go back, let's recap. So we'll show you this one more time. So we'll wrap it up. We'll show you one last question, and then you guys can bolt whenever you guys want to bolt, okay? So let me show you this last one. So the diameters of ball bearings produced at a factory are approximately normally distributed. Let's suppose the mean diameter is 1.002 and the standard deviation is 0.006. What proportion of ball bearings can be expected to have a diameter under 1.02 centimeters? So let's actually see what that looks like. We always start off by stating the question. Under meaning less than or equal to. Proportion of x that's less than or equal to 1.02. Okay? So if you're using z-scores, the first thing you're going to do is you're going to take this 1.02 and change it to a z-score. Then you're going to look at your z-score and you want to find the proportion that matches up with the z-score for 1.02. If you're using StatCrunch, which is the easier method to do, okay, make sure you've got your mean. That's 1.002, and your standard deviation is 0.006. Okay, so I'm going to go to StatCrunch. Okay, we're going to use our thing, but now we're going to change our mean to 1.002, and our standard deviation was 0.006. And we want to find the proportion that's less than or greater than 1.02. And we can see most of our, oh, I'm sorry. Were we supposed to do less than or greater than? Less than, yeah. We were right the first time, so less than. And we can see almost all of them, almost the entire graph. No, 99.85% of all of our ball bearings will be less than 1.02, or almost the entire curve. If we use our 68, 95, 99.7 rule, we can see that. Okay, oh, mean is 1 point, I don't know why I put it in 1. There we go. 1.002, 1.096. Okay. All right, 0.9986. Cool. All right. So the homework problems, I think I gave you some suggested homework problems. If you're still doing homework problems in my stat lab, I will open up the sections for 7.1 and 7.2. And I can see Rachel's has pretty much reached her limit for tonight. I can see it. Okay. So I walked you through it. So that's 7.1 and 7.2. 7.1, we started with some uniform distributions. That was just the rectangles. Find the area underneath that one. I think I gave you about one problem of those. Okay. I gave you, it looks like there's a lot of problems that I gave you, but a lot of them you can just simply do in StatCrunch by just punching in z-scores and looking for areas to the right or to the left. Okay. Cool beans. That is it. Tomorrow I will post a time. I'll do an hour of homework problems that you can just pop in, and anytime you want to come in and ask any questions, I'll be available for an hour tomorrow. Okay, so I'll post that tonight. Otherwise, have yourself a great evening. Like I said, the homework problems 7.1 and 7.2. Stay safe. If anybody have any questions before you guys head out?
Professor.
Sure.
This Shakira, I have a question. For the homework on my stat lab,
yes.
Which one are you grading?
I'm gonna open up 7.1 and 7.2 tonight. You're just gonna do 7.1 and 7.2.
Okay, and that's due next class.
That'll be due for next class.
So, okay.
Quick question. Out of all the questions that you gave us previously before we signed on, is any of that pretty much just practice work, or is it graded work?
Right. I will give you guys all homework grades. I'll put them into your grades for this quarter as well.
So as of right now, from the time last meeting class to now, we have nothing that's due for graded work, do we?
Correct.
Okay.
Just the chapter 4 assessment was the only thing that.
The chapter 4 assessment, right? That was the one with you guys had to do for the burger.
Oh shit! I'm okay.
The cheeseburger is due. You're right. I'm sorry, Leanna. You're right. So we do. You guys still owe me a cheeseburger assessment 4.
Which
I'm
you
sorry.
did extend
That's the chapter 4 assignment. Yeah. I think some of that I didn't understand all of the questions, so I was a little bit stuck on that. And then I was unable to access tutoring, so I wasn't sure what to do with that.
For the cheeseburger problem? For chapter 4?
Yes, correct.
Like I said, I will open up time tomorrow too, so you can ask me that tomorrow as well. I'll give you the hour in which you can do that. And plus, I did have a session where I did chapter 4 stuff that I will post. I still have the video of that. I'll put that on YouTube, and I'll give you the link for that. And it will probably also have subtitles for you as well, Eduardo, so you can look at that as well, the session that we did last
Okay.
week. Okay?
Okay, great. And then I also had one additional question. I was missing something about it. Was there an assessment you said last week?
No, I just
For
posted
chapter,
chapter 5 and 6. I just posted this week.
Where
I
is
just-
it at? I can't find it.
I can't find it either.
It says in place of face-to-face.
But I looked in there and it's not in
There's
there.
nothing in there?
No.
Okay, I'll make sure that it goes in there.
Professor,
Yes,
I thought the chapter 4 assignment was the cars.
That was the
with
first
the
one.
scatter plot.
yeah, that was the
I-
first one.
I never did the cheeseburger assessment.
Okay,
Is there a way that you could do like change the problems up or something, and I can retake it? Because I thought the chapter 4 assignment was the cars where you
Yeah, that was
enter in
the-
stat crunch.
the cars assignment was the introduction to chapter 4. That was a while ago. But instead of having a chapter 4 test, I just gave you an assignment where you guys used all the concepts from chapter 4 to, what was it? Like you guys were predicting the number of calories in a cheeseburger, given the number amount of fat. So I'll repost that as well if you want to take a look at that. And I'll spend the time on that. So you can download it and you can work on that as well.
Okay, thank you.
I submitted mine. Apparently that I have a second chance or something like that until April 2nd. What is that about?
Like I said, if you want to, I'll grade it and I'll get it back to you. And if you want to try to get a higher score, you can resubmit it.
Okay.
Okay?
That's for the cheeseburger assignment, correct?
For the cheeseburger assignment, correct.
And that's be able to submit.
Mhm.
So cheeseburgers do everything else on the homework. That's a homework.
So the only thing that's due for right now is the cheeseburger assignment. I'm going to see what happened with the chapter 5, chapter 6. You guys, I'll see where that is, because I thought I posted it today, but if it's not there, I'll find out where it is. And if not, everybody gets a good grade on it.
I'm mad at that.
Professor,
Yes.
if I don't have stat lab,
It's okay, as long as you have access to StatCrunch.
yes.
Yeah, that's fine. Then I posted some problems that you can do out of the book, and it's in your announcements.
Okay.
Okay.
And do I have to turn those in? to
No,
you?
those are just practice problems. Again, I give everybody a flat score for doing homework problems.
Okay.
Just to be clear, the chapter 5 and 6 are due this Friday.
Well, I'll extend it because I thought I posted it yesterday, but if it's not, if you guys can't find it or anything like that, then I'll have to find out what happened to it. I tried to convert everything to an online version, so maybe it didn't get posted. I'll have to find out what happened with that. And if I can't find out what happened to it,
So
we'll
five
do
and
something.
6 is not the hamburger one, is it?
That's chapter 4.
So 5 and 6 is a separate assignment.
Separate thing, separate assignment.
So it's 2 assignments plus the homework.
It's
Yep.
But you gotta find 5. Okay, I understand. I
Okay.
get it.
That's the assessment, right? 5 and 6, like an exam. Kind of.
Yeah, it's just like 10,
Like the
it's 10 problems. And you guys, like I said, you'll have plenty of time to do it. Okay?
Okay.
It is timed, but it's like 3 hours, you said, right?
I gave you 3 hours for 11 problems. It's not going to take 10 problems. It's not going to take you that long. Some of them are just one part too. Some of them are only one part. Some of them are, and I think the last 2 are the only ones that are multi-parts. So I think the first 9 are just one part, and then the last 2 are your multi-part questions.
Is that counted as our midterm?
I didn't give a midterm. We just never had one. We never had time. So
Okay.
it'll just be the next test, okay?
Okay.
But we've only got one assessment in. I want to try to get you at least one more before, okay?
Okay.
Like I said, we're making the best of it. Like I said, this is not your traditional online class, but we're going to make the best of it, okay? So hang in there. So hang in there. And like I said, does anybody have a preference time tomorrow, morning, afternoon? tomorrow?
Tomorrow?
I'm just gonna give you guys an hour that you guys can ask me any questions on the chapter 4 set, or you can ask me questions about the homework.
I have to work at 5 o'clock, so it could be after 6.
The same time, like 7?
I can do that as well.
Make it.
Yeah.
Okay.
Yeah, 7 works perfectly for me.
Okay, sounds good. I will be online at 7 o'clock then, and anybody wants to jump in and ask questions, they may. Okay?
You still can come back and access this video, correct?
Yeah, I will post this one too. As soon as I stop this one class tonight, it'll put into a video, and I'll upload that video as well of everything that's going on right now.
All right.
Okay?
Last question. So every Tuesday and Thursday, we're going to be meeting on here from 7 to 9.
Yep.
Okay.
Okay.
I have a question.
And if you don't make it, I'm recording it. Yeah.
Hello?
Not available.
Hello?
We
Yeah,
can
I'm
hear
here.
you.
Go ahead.
Oh, you can hear me.
I
I,
can-
didn't know. Okay.
I can
So,
hear you.
where do you find the cheeseburger question?
It is posted in the assignments. Still, if it closed, I'll reopen it, okay?
So, in class assignments, or is that it, where I should find it?
It says,
Or other assignments?
It says other assignments.
Uh-huh.
I think that's it. It'll say other assignments. It'll say chapter 4 assessment.
Okay.
And hold on a second. I'll see if it closed. If it closed, I'll reopen it. So I'm looking at it right now.
Did you see mine when I sent it to you?
I probably do. If you sent it, I have it.
Like on email, like right at 12.
Yeah. Yeah. Is it Gabby?
Yes.
Gabby, I got yours.
Okay, cool.
Okay. Yeah, I got yours. You sent it to me with email.
Yes.
Okay. All right.
I'm super nervous about mine.
You're super nervous?
Yeah, I did the PowerPoint option,
Okay.
and I just was.
That's fine. I'm sure it's fine. I will look at it. I'll look at it tomorrow, okay?
Okay.
I had a question as well for that cheeseburger assignment. Are we supposed to, is that like a 2-page written response, or is it 8 slide? Is it the 8th slide? What was it that we were supposed to be looking for?
You're just going to do a 2-page report answering those questions, or you can do an 8-point slide. Either one. You didn't have to do both.
Oh, okay, got
Just
it.
as long as you answer all the questions, you're in good shape.
Okay, sounds good.
All right, I'm looking right now. I think the chapter 4 is still up there, and it's in other assignments. So hold on one second. I'll make share that page real quick so you can see where it is. For those of you that still wanted to know where chapter 4 was.
It's under chapter 4. Like in the chapter 4 work.
Yeah. Hold on. That's not it. All right, this is it. Yeah, so it's if you go over to where it says other assignments, if you click on other assignments, there was 2 assignments for chapter 4. One was a while ago. That was the introduction, but the assessment is right there. That's what the cheeseburger problem. And if you click on that and open that, you can see that's what that will look like.
Can you show us 5 and 6 while you're here?
You do what?
Can you show us the assessment for 5 and 6 while you're on the screen?
Yeah. Hold on a second. In place of 5 and 6. Chapter 5 and 6 assessment. Oh, it says it's hidden from students. Can you guys see that?
Oh my goodness. No.
Hold on.
No, you can't. You have to show us now that you're gonna show it to us.
I have to show you now.
Screen share. The fuck?
All right, can you guys see the screen?
Mm-hmm.
It says availability. Why are you guys hidden?
Item is hidden from
Oh,
student.
there you go, make available. Now it's there. I can show it to you now.
Yeah, let me double check.
So you got a 3-hour time limit.
Mm-hmm.
Okay.
And that's the quiz, is that correct?
That's the quiz, yep. So I can show you what it looks like.
I don't see it. Oh, there it is. It's in face-to-face. In place of face-to-face.
In place of face-to-face.
Yeah. I always look under other assignments or whatever, but in place of face-to-face.
In
Got
place
it.
of face-to-face. So you can see there's, let's see.
And as soon as you hit begin, you have to like take it.
Yeah, as soon as you open it, you guys got, like I said, you got 3 hours.
Okay.
Okay. And Eduardo, I gave you extra time.
Awesome, thank you.
Okay. So that's there. Sample space, let's see, 2, probability, 3 was a probability question, 4, 5, 6, 7, Skittles. 8 was about Skittles, 9 was about Skittles. 10, we've got a 2A table, and number 11 was the only one I asked you that has a binomial question in it. And that's it.
Okay.
Now it's available to you guys too. I'm sorry, I thought that I made sure that it was available to all you guys. Okay, so like I said, you guys got 3 hours. I know it's been a while, so go over your notes. Make sure you guys go into the resources and look at the review guide. I put answers in for the review. So go back to chapter 6, resources. Can you guys still see the screen with the test on it?
Mm-hmm.
Yes.
Mm-hmm.
So I'm gonna go back to chapter resources. Can you guys see that?
Yeah.
Chapter resources. I think 5 and 6, I gave you guys a review. That was a while ago. So if you guys go back to that real quick in Blackboard, I actually posted a key. I don't know, you guys got to let me know if you can see this. Can you guys see that now? Or is you still on the screen for?
We're still on Blackboard.
We're still on Blackboard.
You're still
for
on
5
Blackboard.
and 6.
All right, hold on a second. This is the review. I did do a review, but in this one I had all the answers I put in red. So look that, before you guys take the test, look that over. You may even want to print that out and have it with you. I go through some of all the things and then I put in all the different ones into there, okay? So like I said, I highly recommend you do that before you take the test. Look that over. Every single question that's on the test looks like the ones that are on the review. No surprises. No like, where did he get this problem from? Okay, so it should look pretty familiar, okay? Cool?
Cool.
Any other questions?
No.
All right, guys, thank you very much. This is the big experiment. This is what you guys signed up for. Telling you.
This actually looks bad.
The what?
I actually don't mind this.
Oh, this isn't bad? All right,
Yeah.
well then, like I said, we're making do. We're gonna do the best that we can. And like I said, I'll 7 o'clock tomorrow, you guys can come on and ask any questions, okay?
It's a little bit difficult for me to see the interpreter with everybody lined up. It's a little overwhelming visually.
Yeah, I can imagine. I can imagine it's overwhelming. It's a little overwhelming for me too, Eduardo,
Yeah, I hate
to see everybody in little boxes. I feel like the Brady Bunch right now. I want to look down and wave to you at the little squares. There's Leanna over
Yeah,
there.
yeah, that's exactly what it's
There's
like.
Gabby over there.
Are they gonna refund people who take labs?
Well,
Do you
my
know
daughter,
anything about
my daughter takes labs and she's not having them. So yeah, they're going to refund her. So
Okay, good. Because I haven't heard anything about that, and it's
yeah, there's not going to be any labs.
yeah.
So yeah. Okay.
Okay.
All right.
Bye, guys.
All right.
Bye.
Thanks, guys.
Thank you. Bye-bye.
Bye.
Have a good night, guys.